Hello everyone and welcome to this Nordic Tech webinar, Introduction to DECT NR+. Today's host is me, Martin Lesund. I'm a technical marketing manager for cellular IoT, and with me I have Christian.
Hi, I'm Christian. I'm a product manager for cellular IoT and also DECT NR+ now in Nordic.
So today, just some practicalities before we begin diving into the information. The duration of this webinar will be around 60 minutes, and we expect to have a big portion of this webinar around Q&A at the end. So questions are encouraged. We got a lot of questions in this morning session, so just ask anything around DECT NR+ and what we are talking about there. So you have this question bar in the top right hand corner where you can ask your questions. Every question is anonymous. You can also use the chat, but that is not for questions, and the chat is not anonymous. If you have any questions after this webinar, you can go to our technical support forum, DevZone, and ask your questions there. And of course, this webinar is recorded and will be available on our Nordic webinars page together with the slides. In the agenda today, we will talk about overview around DECT NR+ in the beginning, how and why it was added in as a 5G standard and why this is important. Also, we're going to showcase where this fits into the 5G triangle and compare it a little bit with the other technologies. We're going to look into different use cases where this technology is very well suited, and also we're going to dive into the different network protocol layers. At the end, we're going to highlight the benefits of this technology for the users, and also how Nordic views the future of NR+ and what we're going to do with this technology. So I hand it over to Christian to take away this overview part.
Yeah, so first a little bit of overview to set the stage before we go into technical details on NR+. So there is quite a few radio standards out there today that also compete to solve various use cases with regard to IoT and other things. They come along with regular use cases, and of course from time to time there is a standard coming along that really try to be more universal and actually can solve more universal standards than many of the smaller ones or not so known ones. And now there is yet another radio standard that you guys have to be introduced to and learn to see which one is best for you. So is this just another standard, or is it one of the more universal and good ones? That's what we're going to focus on and try to explain to you today how Nordic think around that. So Nordic Semiconductor, many of you know us very well. We are a leader in Bluetooth Low Energy with 40% market share. We are starting with Wi-Fi with our first products later this year, and we are also established in cellular IoT with a device that support LTM and narrowband IoT. And late last year, we decided and we went public and said that we are also a strong contributor for this new standard, which was developed by ETSI and called DECT 2020 by then. And that we have also been not only supporting it, but we have been a main contributor to the physical layer and also contributor on the medium access or MAC layer of the specification. And if you know Nordic, you know that we are a company that only support major and open standards, such as BLE, Wi-Fi, and cellular. So it means from our point of view, we really see NR+ as an opportunity to develop another major open standard that can solve a major should we say, gap in the IoT market. There is no wireless standard today, as far as we see, which is non-licensed and can especially go into use cases where existing open standard and big standards, either they are sub-gigahertz, 2.4 gigahertz, or Wi-Fi, can fit very well. And that's how we decided to go into this and why we think it can be really a solve and be a big missing piece in the IoT world today. So with that, let's look at how we see the key advantages around NR+ and how we look at that. So first of all, it's been added as a 5G standard and approved by the International Telecommunication Union as a 5G standard that can meet some of the tough requirements set by them. This is not important because it's a 5G standard, but it is important because with being approved as a 5G standard, it means that NR Plus meets a set of very, very tough technical requirements to meet use cases that are defined by ITU. The second big thing about this is that every 5G standard that is approved today is part of cellular license standard and only allowed to be deployed if you have a license to use the spectrum band, such as if you are a mobile network operator. NR Plus is a 5G standard, but it's license exempt, meaning that everyone, you can deploy your own private network using a global 1.9 gigahertz band without having license for that. And you can deploy global, you can deploy local network, you can also deploy local network on top of each other with any issue, meaning that this is the first technology where you can actually deploy your own private network, but still utilize a very robust standard approved by ITU as 5G. It's very reliable. It's built to be very scalable. You can basically put up a small mesh network of around 100 nodes in 1 square kilometer with redundancy. And you can continue and add and scale devices up to 1 million nodes. And you will still achieve this 99.99% reliability that ITU demands because to call it a reliable technology. And all of that is built into the lower layers. So you achieve this reliability without having to add a lot of top on the protocol layer, on the application layer to do packet checking, rechecking, retransmissions, and so on. And that means that you can achieve super high reliability in your network without even having to think about the details on your application side. Going a bit back into 5G, it's important to spend some time on that to also make you understand how NR Plus fits into that. So 5G is formally also known as IMT 2020, or International Mobile Telecommunication Standard set in 2020. So the International Telecommunication Union, ITU, they define these overall standards for telecommunication and publish them around every 10 years or so. So when this was done now, we went from 4G into 5G, 5th generation of these standards. And they then set the technical requirements for how to utilize the spectrum, but also around the use cases and what are the technical requirements to solve the different use cases they see for mobile and broadband communication. So in this 5G triangle, you basically have three things that they focus on, have set requirements on. One is enhanced mobile broadband that you see on top. This is the 5G new radio for cellular that you are already seeing and will see in your handheld devices, in your tablets, at home for streaming over cellular instead of Ethernet and so on, really high bandwidth for consumer devices. And then you have 5G for MMTC, or massive machine type communication. So this is defined to support constrained low power nodes in massive deployment, ending up with basically billions of connections around the world in a few years. And this is where existing technology, LTM and narrowband IoT, exist. This was already defined as part of 4G or in 3GPP release 13, but from release 15 in 3GPP, it's part of 5G. So that's the two technologies that really exist today for massive machine type communication as part of ITU's definition. And then the third thing is this URLLC, ultra reliable low latency communication. This is also defined now in 5G as 5G new radio that have very specific set of requirements to support those use cases. It's a different type of radio than what you typically will build for MMTC or enhanced mobile broadband. So these are radio that have to support down to 1 millisecond latency. They have to support 99.999% reliability on packet level, very big and messy big in network. And it's typically developed to support future needs of wireless for autonomous driving. It can be, remote surgery, critical infrastructure, factory automation, robots working next to humans, and so on, where you need the absolute highest possible reliability. And the thought here is that reliability is so good that you can actually replace wires and Ethernet inside factories and so on. And what NR Plus is designed to achieve and has been approved now in ITU as part of 5G is that it's approved technically and saying that this technology, this radio standard, is technically capable of solving the use cases and the requirements set for MMTC and URLCC. And this is what means that when we talk about NR Plus can scale to millions of devices in a square kilometer, that's exactly what MMTC is designed to do. And when it supports ultra reliable low latency communication, it means that it can also support down to 1 millisecond latency between nodes. And it can support this 99.9% packet level reliability between devices. And beyond there, there's a lot of other technical requirements that we don't have time to talk to today, but maybe that sets a little bit of stage for you guys on how this fits in 5G. With that, it's also important to understand that being a 5G, this is not a cellular technology. It's a technology where you can deploy your own private network. You don't need to license a band or spectrum. You don't need a SIM card and so on. But in the end, you will need some type of gateway, right? To get your devices to connect to the internet in some way. And Martin will talk more about that a little bit later, how that is done. We then look at some of the key features, and some of the things we will talk about today in more detail is, as mentioned, it uses a license accept band around 1.9 gigahertz, which is available all around the world, which makes it easy for you to build and make devices because you don't have to think about utilizing different bands all around the world. It supports point-to-point, star, and mesh network topologies, so all type of technologies. As mentioned, it's designed to support low latency operation down to 1 millisecond between devices. It's built on the same, so you say, technical standard that is already proven in cellular technology to reach the same reliability. So with cellular, you have billions of devices out there today. It's the most secure, most reliable network that exists on the globe. And if you then look at NR Plus and cellular, you see a lot of the similar techniques that is used on physical and lower layer to achieve the same type of reliability with cellular as with NR Plus as with cellular. It's built to be very scalable, to go to very big network sizes and many millions of networks. And this is exactly also in order to try and create a technology that can really fit and be built around many use cases. The physical radio itself is also very scalable. You can build a radio that supports down to a few megabits of data at physical layer up to several gigabits of data, meaning it can also support all type of use cases from simple IoT nodes up to very demanding streaming applications, for example. It uses up-to-date security based on AES, as you see with many other modern radio standards on protocol level. And then on top of that, it can work basically flawlessly with higher end protocols on application or packet level, such as TLS or inside IPv6 and so on. And NR Plus is designed on radio level so that you can really build very low power devices. We do not have capacity in this first webinar to talk detail around low power, but thinking about a very low power sensor node that wake up now and then to send a little bit of sensor data over a NR Plus network, you can build devices that achieve an average power consumption below 10 microamp, as you also do with other radio technologies today. With that, Martin will continue. He will go into some of the more technical detail to explain to you guys how this can be possible and some of the key capabilities around NR Plus.
Yeah, thank you very much, Christian. So now we're going to jump into the technical part of the first non-cellular approved technology for 5G. And the first thing I want to dive a bit into is this license exempt 1.9 gigahertz spectrum, which is more or less globally available, and it's listed here. The ranges. First off, what is the benefits of having a global spectrum? This means you can have a single product that would work around the world without having to have different designs depending on the regions that you're deploying your product. So in the 1.9 gigahertz range, you can see the list here for the different ranges around the world. The ones that are grayed out are not supported yet. That is Japan. It's under discussion right now, and also in India. In India, you have legacy DECT support, but the DECT NR Plus is not approved yet, but we see that it's going to be that in the future. NR Plus also provides coexistence with the legacy DECT band, legacy DECT on the legacy band, and the only country that does not support 1.9 gigahertz right now, it's China. The China Mobile Telecom has blocked and allocated this band. So right now, the only option, or one of the options that we see, is that China could start with a 2.4 ISM band instead. So there's a separate DECT working group trying to influence China right now around this. So the initial applications that we envision where DECT NR Plus is suitable, we see that it's very suitable for typical smart industries, smart cities, and also professional audio. So in smart industries, you can have large factories, warehouses, smart buildings, asset tracking, and moving robots. So basically areas where we have several hundreds of thousands of devices connected in the same network. For smart cities, it's the same thing because of the highly scalable features of the technology. You can have different networks in a city area. Let's say you have all the street lights connected to your own network. You can also have networks for the parking sensors, traffic management, and bin collections, for example. We're going to dive a little more into some of these use cases and what they could be. And for professional audio, you also have support for the ultra low latency, and that could be suitable for audio applications with regards to having large arenas connected to the same audio output, and the audio spread out to different headsets, for example. Also for stadiums, but still keep the high bit rates for professional audio quality. So let's look into a smart industry application type of thing. So on the right-hand side is trying to put together different devices connected in a smart industry. Let's say a factory where you can have self-driving vehicles, massive amount of connected equipment. That could be tools, robots going around capturing packets, and also let's say robots building cars where you need to have low latency requirements because of it can be mission critical stuff, so you need low latency. And one of the nice features with NR Plus is that you have self-healing and self-organizing properties in the lower physical layers, in the lower protocol layers, which means that if a device goes out of the connection area, the network itself will self-organize to make sure that the data is sent out reliable around the network. So you can have, of course, moving parts in the network, and it still will autonomously fix itself and reorganize based on what it needs. And also the nice property with NR Plus is that you can have your own secure private network. Another area would be the smart city. And here you can see a kind of use case where you have smart streetlights. You have of course, already several thousands and millions of street lights around the world. So you can imagine all those connected together through DECT NR Plus, where you send information for maintenance, dynamic light control for energy saving. Let's say that you only have the lights on when you know that there are cars driving in that direction, for example. So you can shut down the lights when it's not needed. This is typical great use for rural areas where you don't need to light up all the time. And of course, you can gather real-time diagnostics and include different sensors to manage traffic control. Let's say you include a speaker around a bus station to give information for the people around. and all this can be sent through the same DECT NR Plus network. And then you can have a sync node which connects up to the cloud, let's say through LTM or NB-IoT to send the device data up to the cloud. Yeah, more about what devices could be connected to at least one of these street lights. You can have parking sensors, you can have wearables, professional audio equipment connected and moving between these streetlights, but still keeping the connection and getting reliable data. So you can imagine all the moving devices and the streetlights acting as the base station for these devices for the data transfers. So hopefully that gives you a bit of overview of what type of application could be suitable for DECT NR Plus. And now we're going to dive into the more technical parts of the protocol layers. So we're going to go to the physical layer and also the medium access control layer. And then we're going to talk about the data link control layer, and then at the end, the convergence layer in the DECT NR Plus technology. So first off, we're going to start with the physical layer. So instead of reinventing the wheel, DECT NR Plus builds upon true and trusted technologies and features from the cellular world as well. So many of these names and technologies or features may be known from before for many of you people, if you know cellular. And one of these nice features is supported in the physical layer is this cycle prefix OFDM modulation for both uplink and downlink. And you also have multiple input and multiple output support. So what does this mean? So for OFDM, you can see a figure on the left down side. Regular frequency division multiplexing at the top there. We see the different frequency channels beside each other. While in OFDM, you see the overlap, which means you can save a lot of bandwidth here. And for multiple input and multiple output, this enables for more reliable transmissions of data, while also increasing the data rates, because you can have several TX antennas and several RX antennas for the devices. And in the physical layer, we also have nominal bandwidth scaling from 1.728 megahertz up to 221.84 megahertz. And also you have subcarrier spacing, which is scalable from 27 kilohertz up to 216 kilohertz. More about the physical layer, you have a physical data channel modulation supporting BPSK, QPSK, 16 QAM up to 1024 QAM. And this is similar to that we have in cellular. We also have support for turbo coding rates, as mentioned or listed here, and also support for FDM with the TDMA, so that's frequency division multiple access with time division multiple access. So that's for the based channel access. So on the right hand side, you can kind of see a figure trying to showcase what this actually means. So you can have several boxes of data in the same frequency spectrum here. And the DECT NR Plus has a high data rate scalability. The spec itself scales up to 9 gigabits of data rates, so that's quite high, but our initial plan is to support 3 megabits per second and optimized for low power devices. So we are kind of not looking into the ultra reliable area. We are more into the massive machine type communication area, at least in the first phase, as we see it. Other things in the physical layer at this nice features is this hybrid automatic repeat request methodology. So this means that in the figure down here, you can see a transmitter and a receiver, and you send data 1 to the receiver. Data 1 receives this and acknowledges this packet. Okay, I received it. You can send the next data packet. And the transmitter sends data 2. This time, the receiver doesn't receive everything. So it buffers what it has received and tells the transmitter, okay, not everything is received here. So then the transmitter sends the rest of the data again. And then the hierarch processing puts all of this together to get the data to here. And this is all happening on the physical layer. So no interaction of the upper layer are needed, which means you save a lot of resources and also makes the system more reliable with regards to not losing data packets and important information. So that's a very nice feature to have in our technology. And here you can see the basic operation bandwidth channel is 1.728 megahertz, and the data packets are sent in this 10 milliseconds frames, which are divided into 24 slots. This 24 time slots can also be aggregated or split into sub-slots. And for one of these slots, you have 10 symbols. And for these symbols, the first symbol is this STF, which is the synchronization training field. And this is basically where we have the transmission synchronization. So there's no extra synchronization needed here. And next up is the PCC data, which is the physical control channel. And that is differentiating if this packet is a beacon or actually a data transmission. After that, you have the actual, the physical data channel, so the data that you're sending, and this can be variable in length and also transmitted using different modulations depending on the varying of the radio conditions. At the end, you have the guard interval, and this separates the different transmissions from each other and enables the RX and TX switching times. Next up is the medium access control layer. And here in this layer, we have support for point-to-point, star, and mesh network topologies. On the right-hand side, you can see a simulated mesh network with millions of devices connected in the same network. And on the bottom right-hand side, you can see a simplified NR plus network. And the typical naming of these nodes is leaf nodes. They are the corner nodes. They don't have any children. They are connected to either a relay node or a sync node. And the relay node basically relays the traffic from their connected leaf nodes to the sync nodes. And the sync nodes, they are the backbone connection nodes. So they take all in of the data and then sends it up to the cloud or to your control station or what you have in your network. And the nice thing with NR Plus technology is that all these different properties can be interchangeable depending on the network's needs. So let's say you have a moving device and you see that it loses connection, or the sync node doesn't send all the data because it has such a massive amount of data coming in. Another node can suddenly become a sync node, for example. So this is typically built in the MAC layer. So you have autonomously device provisioning and also self-organizing and self-healing features just in the MAC layer. So you don't need to do anything special on the application layer or any top layer because this is handled here. And this makes the technology very nice with regards to reliability and that you don't have any failure points. With regards to the identification of the networks, that is also handled in the MAC layer, and you have support for ultra low, high density node networks because of the way these IDs are structured. So for the network ID, this can enable up to 16 million unique global networks, and also 256 overlapping networks in an area, because it identifies the network globally and also the network locally in this network ID. And for the radio device ID, that enables up to 4 billion unique radio devices in a single network, and also 65K within the radio communication distance, because this is identified in this identification here by uniquely identifying the radio device and also identifying the receiver and transmitter in this ID. You also have special addresses for broadcast and backend traffic, which are reserved. So now our little bit onto the network routing, how this works in the technology. So this is namings gathered from the specifications itself. So it's not super important for you to kind of remember that you have fixed termination point and portable termination point. Just note that a node can either route devices to other clusters or via a node that sends data, or both. And this means in a whole network, you can have different sets of clusters running on different frequency channels, which communicate to each other, and you can have kind of relay nodes between these clusters, which are in the specification called FT, or fixed termination point. So that's what we are trying to showcase on the right-hand side in the figure here, that you can have several clusters. And you can notice that you have two sync nodes, which are connected to the internet. And now let's see if the bottom sync node is removed or suddenly loses its connection. Now these nodes in cluster 3 suddenly doesn't have any sync node to connect to. So in the MAC layer itself, you have these self-healing properties. So the next thing that will happen here is that the nodes that doesn't have a connection will autonomously connect to the closest the routing nodes to the next cluster and send its data to the top sync node instead. And this is without interaction from any other layers, any other upper layers. That, of course, saves resources and makes the network more reliable. And now over to the layer over the MAC layer, the data link control layer. And here, data link control layer basically provides the necessary segmentations and the packet routing functions for the MAC layer. And on top of the VLC layer, you have the convergence layer. And the convergence layer provides the adaptations function between the application layer protocols and the NR plus radio interface, basically. So inside the convergence layer, you have the security service with ciphering and integrity protection. And also you have a transmission service with segmentation, reassembly, retransmission, flow control, lifetime control, duplicate removal, and delivery order service. And at the bottom, you have the endpoint multiplexing service. So on the right-hand side, you can kind of see the typical structure of the layers in a single node. And on top of that, you would have your application or your IP communication. So you don't have to use IP, but you can, of course, use IP, of course, also, because it's very flexible with regards to that. So that means that you can more easily communicate through, let's say, another routing device that works on thread, and then you can kind of make a router with thread and NR+, let's say, to communicate over the IP protocol. And here we are just kind of showcasing a network architecture of a mesh topology configuration. So on the left-hand side, we can see the radio device 1, which is the leaf node. And in the middle here, you have a relay node. And at the right-hand side, you can see the sync node. So the leaf node on the left-hand side will then transfer its data captured and to the sync node. So in the relay node, you don't need to go into any of the top layers because this is relayed on the lower layers, basically. That is what we're trying to showcase on this slide. So the official specification of DECT NR Plus, or the technical term DECT 2020 new radio specification, is on release 1. This has been developed by ETSI, and we have part 1, the overview specification, available online. So if you want to read the more details around this technology, we strongly suggest you to look into these documentations. You also have the radio reception and transmissions requirements for this technology, and also more details around the physical layer, the MAC layer, and the data link control layer, and the convergence layer here. I also added in a link to the final evaluation report on DECT 2020 new radio. So then all this together brings in the key advantages for this technology. And that is one thing is the self-healing properties from the MAC layer, and also the decentralized features of this technology. It's license exempt and the global spectrum. So since it's license exempt, it's free to use for anyone. And also you have the ultra low latency supported in the technology itself. So it can be used for, let's say, self-driving cars or mission critical applications. Another thing is that you have this high scalability, which is perfect for massive machine type communication devices. Such we expect billions of devices connected in Internet of Things going forward now. And other benefits for the users here. One of the big benefits is the low cost of ownership. You have your own private non-cellular network. You don't need any base stations or infrastructure in that sense, because your nodes would work as the base stations in your network, basically. And you don't have to have a SIM card, you don't have to pay for any subscriptions, and it's easy to install because of the way it connects to each other when you install a new node into the network. Another big benefit is the scalability and reliability built into the technology itself. Like we have stated several times here, you don't have a single point of failure here. It's completely autonomous, and you can expect years of battery life. And of course, the battery life is dependent on the battery you're using, but also how your application is working. It's secure, it's built on proven and secure technologies, and you have support for over-the-air updates to upgrade your devices. And of course, you have the scaling from 100 devices up to 1 million devices per square kilometers. Now, what will Nordic and NR Plus do going forward? So why NR Plus? NR Plus is what we see as a big missing piece in the IoT world. This is a new 5G standard for both MMTC and URLLC using a global license exempt spectrum. This will make it easier for customers that want to have cellular properties, let's say, securely, but not having to deal with any carriers, so they can set up their own private networks without connecting to, let's say, base stations and that kind of thing. And how we're going to do this, we are using existing NRF91 series in partnership with Wirepass to create the first complete NR Plus solution together. And when will this happen? We expect the first Nordic products to be available in 2023. And we encourage you to follow along our DECT NR Plus process, where we have a landing page on our nordicsemi.com page, which we will regularly update with new updates. But you can also, for your own convenience, subscribe to our newsletter, where we will send out new updates when we have any updates for our process with DECT NR Plus. So hopefully this has given you a good overview of DECT NR Plus. So I think it's time for some questions.
Yeah, I agree. Let's dive into that. Looking through here, I think I will start with some of the kind of top level things that people ask about, which we also mentioned, that do you require a SIM card, for example? And the definite answer to that is no. So when we talk about 5G, as mentioned again, non-cellular means that you deploy your own private network. So you don't need a mobile network operator, and you don't need a contract with a mobile network operator to deploy this network. You do it on your own, as you do with license-free technologies today, being Bluetooth Low Energy, sub-gigahertz, and Wi-Fi, whatever you are familiar with. So that's why we talk about it as non-cellular, basically.
So here's a question. If there are two coexisting private networks in the same location, what keeps them private from each other? So you have the built-in encryptions in the technology itself, but yeah, you have this uniquely network IDs. So you won't have any interference with the different devices or other networks. You would only have a reliable connection with your own.
Yeah, the next thing here is there's a few questions around what range you can achieve. So ballpark, we can say, and what we have seen from our initial trials and simulation, that if you look at urban environment, indoor deployments, and where you typically have obstacles, we typically see a few hundred meters of range. And then if you go more open and line of sight, you achieve 2 to 3 kilometers of range. So this is not a super long range technology, but it's definitely on a different scale than what you typically achieve with the 2.4 or Wi-Fi. And not to mention that you achieve this with megabits of bandwidth per device and millisecond of latency. So that's why we see this as such compelling technology adjacent to cellular and comparing to non-cellular technologies today.
Can leaf nodes talk to leaf nodes, or must they go through relays and sync nodes? So the thing here, if a leaf node is going to talk a leaf node, these modes kind of are not static to these nodes. They can change autonomously to a relay node or a sync node, so they can, if a node needs to talk to another node, it can do that either by changing its kind of mode or through another node.
Yeah, and I can comment on that further, that many of you maybe are a bit familiar with other meshing technologies, for example, Thread or Wi-Fi. And what's different between those technology and NR Plus is that those technology are fairly specific mesh routing rules for achieving very low latency, very low memory footprint, or vice versa, very deep knowledge of the network, which leads to huge memory footprint for Wi-Fi, for example. NR Plus gives a bit more freedom on routing. Simply what Martin said, that you can change all of the devices dynamically as well, so that it's able to achieve a lot more different use cases than what these very specific meshing protocols is built for today. I see there's another question here around transmit power, which is also very, very interesting. So in NR Plus, devices can do spectrum sensing to see which spectrum is most free and less busy. But they will also do sensing to understand how much transmit power they can use. So they can transmit with anything from minus 40 dBm up to 23 dBm. So they can do dynamic switching of transmit power which is unlike other non-cellular technology, but typically also what you see in cellular today. So all the way up to 23 dBm.
Here is another question. What does NR stand for? So that stands for new radio. And here's a question. The lower rate implementation for low power devices, will this lead to a reduction in reliability? No, this will not reduce the reliability.
Yeah, there is a related question here commenting that we focus initially on massive machine type communication, and how will that extend further, or how is the specification extend further into other use cases such as low latency or very reliable communication. So our initial implementation will in theory support everything as defined in NR+, whether it's a massive machine type network or low latency or ultra reliable type of network, where we initially focus on higher level protocol capabilities for massive machine type communication with wirepass. And the specification itself as well is complete for all of the use cases and technical requirements that are set in NR+, whether they are for massive machine type or low latency or high reliable type of communication, meaning that you also now have a radio standard where you can combine this in some extent that we mentioned initially. You can build a network with many devices, as you typically understand and see from massive machine type, but you can achieve reliability and latency in this network that you don't achieve with massive machine type communication today.
Here's another question. How many players are there in the NR plus field right now? So publicly, I think it's only Nordic, if I'm not mistaken, which has gone out with this information.
Yeah, on device side. And then you have
Yeah,
wirepass on protocol, and you have also the DECT forum with all the players that are focused on legacy DECT today, which you can go and talk to around DECT if you're interested. Yeah, there is also a commentary and question there. We haven't talked a lot about professional audio application. That's true. That is not our initial focus, but it doesn't mean that the standard cannot do that. It's defined to also support pro audio, and that's been part of the specification process with especially those that are major player in DECT and legacy DECT today, that it can also support pro audio. And in principle, Nordic's initial solution will also be able to support pro audio, but it's not our initial focus. Yeah, there's another question here, or a comment on maybe how do we see with the standard carrier or network operators today? This is very early. We are still in kind of technology evaluation space, but of course, being a specification that contribute or argue for private LTE network, it doesn't mean that it have to be private, right? We can easily see that in a bigger ecosystem here, there is companies, operators, or other that can also build public networks around what initially thought about as private or semi-public, where you have someone taking care of the network and reliability, and with that, you accept some type of cost of ownership, as Martin mentioned, because you don't want to make and build your own and maintain your own network to some extent. And that is something that is fully feasible to see in NR+ moving forward, as you also can see in some other technologies, for example, like LoRaWAN.
good.
A lot of questions around our product plans. I just want to say that that's still a bit early for us to talk about, so we will come back with that and cover more of that later in the year. Quite a lot of questions on very technical detail, which is a bit too early to also cover, but we will come back in Q3 with maybe cover some more specific use cases. How is a certain range, power consumption, reliability, how can you deploy many devices in the same region or many networks and achieve and things like that. That it's also interesting to talk about next time.
Yeah, I also see a lot of questions kind of comparing with other short-range wireless technologies. So we have a slide that we can show for this. this is basically a table that has been gathered from ABI Research, which has compared roughly to other short-range devices on the reliability, security, and bandwidth, and range, and the future proofing of these technologies. And from this table, we can see that the NR Plus kind of directly competes with Wi-Fi and private cellular networks, and also that it excels in range, reliability, and future proofing, while matching other criteria compared to the other short-range technologies here.
Also, some questions around Wirepass, what they will do, their business model, and so on. So there, I recommend that you contact Wirepass yourself and talk to them, and they are more than happy to talk to all of you that are interested to understand more about what they do, what their business model will be, and we can cover more details together with you individually and how our solution will look like together when we release it.
Here's a question for please give URL for complete detailed specifications. So I can recommend you to go to our webinar page afterwards and download the slides, and then you will have everything linkable from there.
Yeah, and there's another question here is asking if this standard is reliable enough to, for example, be used in critical building infrastructure systems such as fire alarm instead of using wired solution. And that's exactly what NR Plus is designed for. It's designed to achieve the same reliability as you have with Ethernet or wired systems today, just as 5G new radio for reliability. You can even argue that NR Plus can be more reliable than a wired connection, because if you have a wired connection, that connection breaks, it breaks. But here you have a network that can actually self-heal. But of course, then you need to build your network infrastructure with nodes so that you know that you have capacity in your network to maybe reroute to a different sink, or that you have placed nodes relatively close together in the sense that if a node disappears, you can actually reroute to other nodes in the network. And in that, you can actually achieve higher reliability in a wireless standard that you can do with even wired standard today. Yeah, there's a question here. We can compare how many devices you can support per square kilometer using LoRa, and that's a very hard thing to do because how many devices you can have also depends on how much data you send and how much of the spectrum you utilizes, right? So what I can say is that NR Plus is designed to support up to 1 million devices per square kilometer, knowing also that you have very efficient utilizing of spectrum here and you have fairly good bandwidth available in most regions. With LoRa, what I see when I talk to people using LoRa, they typically see up to a few thousand devices per gateway because they have very limited spectrum there if you start to send data. But you also maybe comparing a bit of different use cases and capabilities on LoRa versus NR Plus here. Yeah, Martin, you see any additional things? I think we have covered most of the things we can actually cover, and then there is a lot of things here we don't want to talk about just yet. So
yeah, there's many good questions there, but yeah, I think we have covered the ones that we can take today. So thank you very much for listening today. And if you want to sign up for any new webinars coming up, you can go to our webinars page and look into there. Personally, I will highly recommend you to look into our best practices guide for cellular IoT, 29th of June, which you can register to now.
and stay tuned, guys. We will definitely follow up on NR Plus with more technical detail and more product details as time goes by. I think we are ready for that, and I appreciate all the questions and feedback given today. Bye.
Great. Thank you very much. Bye bye.